Hello and good day everyone. Welcome back to my YouTube channel. This is Sir Marcy and we are still on our second part of Module 2, Week 6, which is all about division of radicals. If you're new to my channel, please consider subscribing and click the notification bell so that you'll be notified with my latest videos. Let's recall first our lesson. First is we're going to simplify radicals. In number 1, what is the simplest form of square root of 24? First step is we need to identify the index. The index here is 2. Remember that the lowest index in radical is 2, which is this one. But then we do not write it anymore. Understood by convention that there is 2. Now, next step is we will apply prime factorization. Prime factorization, we're going to look for a factor of 24. So you can use other factors as long as the product is 24. Here, I'm going to use 8 multiplied to 3. Next is we factor 8 and we know that is 4 times 2. And 4 has a factor of 2 times 2. From here, we can now simplify square root of 24. Since our index is 2, we're going to group numbers by 2. So this one will be considered as one group. So that is now square root of 2 raised to 2. What is left here, which is 2 and 3, will multiply. So that's times 6. Then we will apply the product law for radicals. That is square root of 2 squared multiply 2 square root of 6. By applying the property of radicals, which is nth root of a raised to n, since the index and the power are the same, the answer here would be a. So, going back in our problem, the square root of 2a, since the index and the power are the same, we know that the answer here is simply 2. Then multiply 2 square root of 6. The square root of 24 in simplest form is 2 square root of 6. Let's try to have example number 2. We have square root of 50x cubed b raised to 6. First is we're going to identify the index. The index we have here is 2. Then we apply prime factorization for 50. Let's say I'm going to use 5 multiplied to 10. And this one is 5 multiplied to 2. In this example, I can rewrite this in this way. That is simply square root of, we have, again, look for a number which is by 2. We have 5 here. So that's 5 squared. Then, we're going to place the other factor here. So this is the group of perfect nth square. Okay? So this is the group of perfect nth square. Nth root, sorry. And this one is the another factor. Since 5 squared is a perfect nth root or perfect square, I will place it here. And 2 here will be placed on the another factor. Next is if we're going to divide 3 by the index, there is a remainder 1. So therefore, I'm going to place x squared here. And this is the perfect square root. And the remaining x will be placed here. Next is 6. 6 when divided by 2 by our index, that is actually divisible by 2. So I will place here, meaning to say that 6 is a perfect square root. Okay? So again, these are the perfect nth root or perfect squares. So that means we can simplify this part. So we can cancel this out. We know that the index and the power are the same. So the answer is 5. The same goes with this one. So that is 5x. 6 divided by 3. So that is b cubed. Then we will just copy the other factor. So we have here our answer. 5x b raised to 3 times square root of 2x. So I hope you remember how to simplify radicals, and we're going to apply it in our lesson, division of radicals. Let's go! Good day, everyone. My name is Sir Marcy. Our lesson for today is all about the division of radicals. Are you ready? Let's go! In my previous video, I already discussed how to divide radicals. Again, I'm going to give you the steps on how to divide radicals. To divide radicals, divide the coefficients if any, divide the radicands of the same index if possible, and rationalize the denominator so that no radical remains in the denominator. Let's try to divide square root of 56 all over 7. If we're going to get the quotient of square root of 56 all over 7, first is we'll try to factor square root of 56. That is square root of 8 multiplied to 7 all over square root of 7. Next is we can cancel out 7 and what is left now is square root of 8. We can also get square root of 8 by directly dividing square root of 56 divided by 7. So we have now our answer is square root of 8. But square root of 8 can still be simplified. By prime factorization, we have 4 multiplied to 2 and this is 2 times 2. Then we can rewrite this using the product law of radicals, that is 2 squared multiplied to 2. And we have now square root of 2 squared multiplied to square root of 2. If you still remember, when the index and the power are the same, we can cancel them out. And what is left now here is 2. Then a fixed square root of 2. So the answer of square root of 56 all over square root of 7 is only 2 square root of 2. Okay, I have here example number 2. Let's try to divide square root of 18 all over 2. If we're going to factor 18, that is simply square root of 9 times 2 all over square root of 2. Again, we can cancel out 2 and our answer is square root of 9. Just like what I've said in our previous example, you can directly divide square root of 18 all over square root of 2 and the answer is square root of 9. And we know that square root of 9 is a perfect square. When we get the square root of 9, the answer here is only 3. Okay, let's try to have example number 3. Let's say we're going to divide square root of 4 all over square root of 36. We know that 4 and 36 are perfect squares. So that means there is a root. Okay, so the square root of 4 is 2. And the square root of 36 is 6. So our answer here is 2 all over 6, or that is simply 1 all over 3. Let's have example number 4, square root of 15 all over square root of, we have 12. If we're going to divide square root of 15 all over square root of 12, so again, they are not perfect squares, so we're going to factor. That is square root of 5 multiplied to 3. Also, we have square root of 4 multiplied to 3. So this is cancelled out. Then we now have square root of 5 all over square root of 4. And let's check if there is a perfect square. So if we're going to examine square root of 5, it's not a perfect square, while square root of 4 is a perfect square, meaning there is a root. So we can simplify square root of 5 all over square root of 4 as square root of 5, and that's all over square root of 4 is 2. So our answer here is square root of 5 all over 2. And we have here our example number 5. Suppose we're going to get the quotient of 15 square root of 6 all over 3 square root of 2. So this means that is simply 15 all over 3 divided by 6 all over square root of 2. So we know that 15 divided by 3, that is 5, and square root of 6 divided by square root of 2, the answer is square root of 3. So, our answer here is 5 square root of 3. Let's have our last example. How about if we're going to divide square root of 162x raised to 5 all over square root of 2x? If we're going to get, or if we're going to divide this, that's simply the same as square root of 162 all over 2 divided by x raised to 5 all over x. When you divide 162 by 2, that is simply square root of 81. And we apply here the law of quotient wherein they have the same base. And to get the quotient, we simply subtract their exponent. So 5 minus 1, that is x raised to 4. From here, we can now simplify square root of 81. We know that 81 is a perfect square, and if we get the square root of 81, the answer is 9. To get, and also x raised to 4, it's a perfect square, so if we're going to get the square root of x raised to 4, we simply divide 4 by the index 2. The answer is x squared. So therefore, the square root of 162 x raised to 5 all over square root of 2x is simply equals to 9x squared.